Hello everyone, Mr. Hissner here, and today we are going to finally start applying this logic to something more familiar. So we're going to be applying our logical ideas, these conditional statements, these inverses, converses, to algebra. Now, I know that might seem weird, but we're going to start proving that we can use algebra. We're going to do it by using logic. So let us start by, what we're going to want to be doing now is those good old-fashioned taking the notes. So we will be taking these notes and then submitting these later. So make sure you got your pens and your pencils available. So let's do the addition property of equality. So again, this is the properties of equality, and most of you will, recognize this and think, duh. But if two things are equal, then it is true, if A is equal to B, if I can write a B, it is true that we can add some number to both sides without changing that equality, without breaking that the idea of equality. So if you have 3 is equal to 3, then you can add 4 to both sides, and you'll have 7 is equal to 7, right? And we know this. That's why we add things to both sides. What about subtraction? Very similar. If A is equal to B, then we know that, again, we can subtract some number C from both sides as well. Multiplication, again, we know that if the two numbers A and B are the same, then we can multiply some number to both sides, and that will maintain the equality. So if A is equal to B, then A times C is equal to B times C. And division is the same here. Again, these are all properties of equality. If these are conditionals, these are conditional properties. If A is equal to B, then A divided by C is equal to B divided by C. So these are all the conditional statements for this. Now the distributive property, we remember the distributive property. We can do a distribute here. And so if A is equal to B, then it is equal to, well, we just distribute it, AB plus AC. AB plus AC. We also have the substitution property. We've been using substitution property often, right? So if we have A is equal to B, then A may be replaced. Then A may be replaced by B in any expression or equation. So we can plug it in. The reflexive property is A is looking itself in the mirror. Reflexive property, A is itself. It is equal to itself. The symmetric property is A is equal to B. If A is equal to B, then B is equal to A. So we're allowed to flip-flop these around. If X is equal to 21, then 21 is equal to X. Remember that. We do that oftentimes in algebra just to make things look better. And finally, the transitive property. Now, this is something we're going to use a lot. So if A is equal to B and B is equal to C, then A is equal to C. This is the transitive property. I like to think of it as being transportational, right? It's taking A and moving it all the way to C. So it's like transportation. All right, so make sure you have all of this down, and I'm going to be expecting you guys to hand this in. And then what we're going to do here is also just have this idea of a proof. No, I'm going to end the video here. We'll start this in the next video.